So if I ask you to find a max or min of f, okay, so this is back in Unit 3. Unit 3 helping us understand Unit 7. And I say, what's the max, min, and f? What do you have to do? What do we have to do? Beautiful. Take the derivative, set it equal to 0, do our friend, assign it now, right? And it's like, boom, boom, positive, negative, whoops, positive, negative, positive. That was f prime, and f prime tells us f, going up, going down, going up. We would say this location would be the location of a max. This location would be a location of a min. We know signs are all consistent because we found all the zeros. Signs can't change again. All right. Well, we're going to be asked to find maxes and mins of position, or maxes and mins of velocity. And what we'll realize is like, oh yeah, that makes sense. Here's position, changing it from your notes. How to find a max min position. Okay, well, you take the derivative and set it equal to 0, just like Mr. Messer told me to do in Unit 3. What's the derivative of position now? Velocity. Okay, now I'll factor to solve because I don't have a calculator. And you'd say, okay, 0, 1. This is x prime. You got positives, negatives, positives. That's telling me x is increasing, decreasing, increasing. Right? But how have we now thought about this? This is v. This means I'm moving right, left, and right. Cool? So yes, at t equals 0, we would say that's a max. T equals 1, we would say that's a min. But how else can I describe a max or a min of position? Boom, there's one thing. What do we notice about the maxes and mins? When we change direction. When we change direction, okay, that's one thing. Those are my zeros of x prime. The zeros of v, that's when we change direction. What else do we notice? It would be if I go to the right and then go back to the left. My max position would be when I'm furthest to the right, right? We are going to be asked questions about maxes and mins, but just a little bit differently. It's going to be like, hey, when is my position furthest right? You got to understand, oh, it's just a max position. And if I asked you, like, when am I furthest right, and I gave you, say, and we'll look at this in a second, and I gave you the velocity, and I gave you the areas, like, you'd be able to figure that out. You'd be like, oh, well, I can find my position here, I can find my position here, I can find my position here. What are those? When my velocities are 0. What are those? When we change directions. And you'd be able to figure out when I'm furthest right just by comparing the position. Does that make sense? So it's really what we've done, but it'll make sense what we're doing based on how we know. Like velocity means I'm moving right, moving left, furthest right, max position. It's just doing what we've been doing more. Only we're going to focus on times when we change directions. Those are going to be like the maxes and mins of our position. Those are going to be when I'm furthest right and furthest left. Now I'd like us to actually go here and look at this question, but I want you to eliminate this here. And I want you to be given that x of 1 is equal to 5. Now it's like, I ask you, I know it takes a while for you to find it, but you find it. Furthest right. You can think of this as a max position. You can think about it when x prime equals 0. You can think about it, oh, this is v, this is x prime, this is 0, this will sound, yes, but like, you should be able to understand the motion of your particle. And since you now know about areas being displacements, you know about how far your x is increasing, or how far you're traveling right, how far you're traveling left, how far you're traveling right. You guys should be able to figure this out. And what you figure out is that if you start at 1.5, you know that after 2 more seconds, you're going to be 4 units to the right. After 2 more seconds, you're going to be 3 units to the left. And then after 1 more second, you're going to be 1 unit to the right. You know, these are our candidates, right? It's like the only positions we have, and we know that like this is when my velocity is positive. This is when my velocity is negative. This is when my velocity is positive. This is a potential max. This is a potential min. Right and left, left and right. Like this falls along with our understanding from unit 3, when our derivative equals 0. And I'm furthest right at t equals 3, position's 9. But am I furthest left here, where x prime or v goes from left to right? I change direction. Am I furthest left at x equals 5? No. I'm furthest left at x equals 1, at a time of 1, at x of 1. Now, where is this? This is where I started. So, I'm asking you to find a min, but the min isn't at the location that I thought it would be. The min, from our knowledge of unit 3, usually is occurring when a derivative changes sign from negative to positive, or when I'm going from left to right. But a starting point is a min. Okay? And that's actually the only thing that is new in this lesson. We'll go back. Is that if I'm given a closed interval from 0 to 3 seconds, and let's say I'm finding my overall maximums of position, and I had 0, I found 1, but I'm stopping at 3. I have an interval. And again, this is my velocity, and I realize that I'm going to the left and to the right. We know for a fact where either a max or a min is. We don't know about the other one. Which one do I know? It's like, oh, this has to be a min position at this time, or this has to be a max position at this time. Tell your neighbors. 1 has to be what? A min. Okay, again, this is like what we've done before. This is like x prime, this is x. This is telling me x is going down, this is going up. This would be a min position. Or you could be asked one of my furthest left, and you're like, oh yeah, I go to the left and I go to the right. If I travel to the left, and then I travel to the right, wherever this is, right here, that's got to be my min. Okay, cool. So my position at time 1, which is -1. How do I know that? I have a position function. That's going to be my min or my furthest left. Does furthest left have to be a negative position? No, we saw with our graph because the furthest left is a positive position. But now the question is, when am I furthest right? Now, most of us would guess 3. Why? Because like 0 to 1 is less time than 1 to 3. I had more time to increase. But what I want you to know is like, you got to be careful. Don't assume it's 3. Just know that it has to be an endpoint. Okay? Or has to be. We have to consider endpoints as possible maxes and mins. And the only way to confirm things is to actually find positions at these endpoints. So my position function was 2t cubed minus 3t squared. So my position at 0 is 0. My position at 3 is going to take a little bit of work. 3 cubed is 27 times 2, which is 54, minus 3 squared, which is 9 times 3, which is 27. So I do get 27. Yes, my hunch, because between the first second and third second, there's more time. My hunch that it's the third second is now confirmed. Now, what we did is really, we found the position at all of our candidates. And we just compared them. What are our candidates for maxes and mins? Well, it's typically when derivatives equal to 0. But now we also need to just check endpoints. And this is called the extreme value theorem. That maxes and mins on a closed interval could occur when a derivative equals 0, we're used to that, or at an endpoint. I don't love this graph. I think it's going to confuse students. Typically, we're given the graph of velocity, we're given the graph of the derivative. But what I'm saying is like, if this is the graph of f, or if this is the graph of position, and I ask you, what's our max and min position from 0 to, I don't know, 5, and I close off. You would say, okay, when the derivative equals 0, that's there, but then the max would be here at an endpoint. I don't want that to confuse you, so like if this doesn't make sense to you, don't worry about it. Okay? Now, what the extreme value theorem says is that like, hey, you want to find overall maxes and mins, compare your candidates. Compare what essentially we were talking about our position values when we change direction and our endpoint. We compared our position values at our endpoints to when, and as well as when our derivative equals 0 when I change direction. And then I just said, well, these are my 3 possibilities. Whichever one produces the minimum value, that's furthest left, that's my min. Whichever one produces the maximum value, that's my furthest right. I win. Okay? So, here's another position function. When am I furthest left and when am I furthest right? From 0 to 2. It's a great example. It's just like what we just did. Actually, it's the exact same thing. So I'm going to change it up. Let's do t squared minus 2t plus 3. That's my position. And I don't want to go from 0 to 2. I want to go from 0 to 3. Okay. All right, well, like we know furthest left, furthest right is a max or a min. Finding max is a min, you take the derivative set it equal to 0. Or now we can think of it like if I know the motion of my guy, if I know the velocity, I can figure out when I'm furthest right, furthest left. Velocity is 2t minus 2. I set that equal to 0. I get 1. Really is going to be similar to the one that I just did. I'm looking between 0 and 3. If I plugged in something like 0.5, this would be a negative. If I plugged in something like 2, this would be a positive. This is my velocity. This is the derivative of position. This is telling me my position is decreasing and increasing. So obviously, I know for a fact this is my min. Or if we think about motion, this would be my furthest left because I go left then right. That's one way to just like get your answer. Now the other way would be, okay, I got my endpoints and I have my 0. If I could just quickly and easily compare, where's my position at 0, what's my position at 1, what's my position at 3, these, my friends, are called the candidates. They're the endpoints and when my derivative equals 0. I could plug in 0, get 3. I could plug in 1, I get 2. I plug in 3, I get 9 minus 6, plus 3, and I get 6. And boom. Yeah, that confirms things. I'm furthest left at my least candidate. I'm furthest right at one of my endpoints. Will it have to be the right endpoint? No. Might be the left endpoint sometimes. Yeah. Well, you took the derivative, you set it equal to 0. Do your sign analysis. Do you have to know the sign analysis, I think is your question. No, you don't. If you just take the derivative, set it equal to 0, and then you just go 0, 1, 3, yeah, you're going to get the right answer. Now, what I knew before you would have known is that I knew 1 was going to be the furthest left. I knew 1 was going to be the min because I did my sign analysis. But the candidates test says like, you know what? You want to skip it? Skip it. You're going to get the right answers out of these. Cool? Now, where I'm going to mess you up is ask you when I'm moving fastest to the right or fastest to the left. Same as the first question. Now, the first question gave me the position of 2t cubed minus 3t squared. Okay? Remember that one? And we already took the derivative of this. We found the velocity. We got 6t squared minus 6t. We already did a sign analysis of my velocity. We found that it was negative and then positive. 0 and 1 were my important points. But fastest to the right would be another way of asking that question. Good. You guys are all on the right track. When my velocity is at a max, doing velocity, looking at velocity's max. Now, guess what? This doesn't help me to find velocity's max. You got to remember, to find a max of something, or if this is x prime, to find x prime's max, you got to look at the second derivative. You got to look at v prime. Oh, you're going to have to look at a, like you guys said. And when you look at a, that'll tell you when v is increasing or decreasing. So be ready to take a second derivative. And if we're talking about between 0 and 2, we realize we get 1/2. Should probably plot everything over. Now, we probably would have guessed, oh, 2, you know, if I asked you the question. Because you're like, oh, the velocity is negative, so I'm moving to the left. And then the velocity is positive, I'm moving to the right. But when's velocity going to be at a max? At 1/2. It seems weird, seems counterintuitive, but t equals 1/2 has got to be the max v. Never mind. So my instincts were correct. Darn it. It would have been great if they weren't. Yeah, I messed up. So we're going, and my velocities are decreasing then increasing. Either at 0 or at 2, my instincts at 2 are going to be correct. But what do I have? Candidates. I can immediately eliminate the candidate of 1/2. That's going to be the min. If I'm asking fastest to the right, my only candidates are the endpoints v of 0 and v of 2. And v of 0 using v is 0 and v of 2 is 12. I have to change this note up. I put up here, adjust a little for 22, 23, because these examples are bad. I wanted like a left endpoint to work. I want something in the middle to work. When you do your homework, don't worry, it'll work. All right, so taking derivatives, set it equal to 0. Great. What if I'm given a derivative and given a calculator? I'm given v. And I'm asked what are the locations when I'm furthest left and furthest right. Yeah, just graph it. Just like kind of what we were doing to find some unknown positions. It's like, hey, let's understand the motion of my particle. So we're going to go back and similar to this question, like it helps if we know what velocity looks like. So let's go and graph velocity. Now, I'm probably going to give you an interval, and let's say the interval is from 0 to 6. And hope and pray that it works out nicely is what Mr. Messner's saying right now. I might change that interval. But I will, I'll show you. Hopefully, I want to show you something so you're ready for your homework problems like this. What? I'm probably going to change it. Ready? 3 log x sine x minus 2 minus 3. I like to have y equals 0 graphed as well. 0 to 6. Let's see. I like that. I like that. I don't like that. We're going to go 1, 2, 3, 0 to 4. Changing my mind. 0 to 4. All right. That's better. Okay. What do I get from looking at this graph of Z? What do I know? You're not going to know the answers right now, but at least like what can you tell just by looking at this graph of V? I can tell which direction I'm traveling in or whether X is increasing or decreasing. So I can see This is the location when my velocity is 0, when I'm changing directions. Boom, there's a candidate. When my derivative is 0. Boom, there's a candidate. When my derivative is 0, right? Well, we're going to have to find those candidates. So, boom, let's find the intersection. That's going to be a 3. 0.097. You know what? I'm going to hold on to that number. I'm going to use that again. So here's my velocity sign analysis between 0 and 4. I'm going to call this guy B. Okay? And I'm going to say B is 3.089670. You know what I'm going to do in my calculator? Throw that sucker. X, I want to be B. All right, boom. I'll use that in the future probably. Let's find the other one. Since that's a candidate, let's find that. Now, what are these values? These X equal numbers that I'm finding? Are they positions? Are they times? Are they velocities? Are they times? Very important. 0.367, these are times. These are times. I'll just put dot, dot, dot. Guess what? I'm probably going to use that again, so let's go ahead and just store that now. X is now this. Let's store that as A. Okay. Great. Well, I have a problem here. My velocity is positive, negative, and positive. By looking at this, do I know when I'm furthest right or furthest left? I mean, I go to the right. Here's my dude. It starts at a position 4. I go to the right. How much? I don't know. Not now. I go to the left. How much? I don't know. And then I go to the right. Like, I have no idea. I have candidates, right? I know this could be my max. What else could be my max? That one. 4, right? Because I go to the right, I change directions, go to the left. But then I go back to the right. Maybe I go to the right further. And I end up further to the right than I was at A. Well, I have candidates for my min. How am I going to distinguish which one is the max or min? What else do I know about from last class? We could use, my friends, the areas under B. Because guess what? You can't take the antiderivative of this guy. You want to try to? You want to try to find a position function and then compare the positions? No, I do know that, like, here are my options. 0, A, B, 4. These are my candidates. These are when my derivative equals 0 or my endpoint. But how do we find these? Well, I know this position of 4. How can I find my position at A? Use my position at time 0 and use the displacement from 0 to A. Now, this is where it's helpful. Watch this. Go into our y equals. You remember your friend second calc 7, which was like the first time that we showed how to find areas. We used like this, second calc 7. And then we went to the home screen. It's actually helpful to see it here, because now that we have A stored, I'm going to just go from 0 to A. And boom. It took us some time, but that's your calculator working to do the arithmetic with these crazy functions. What's that 0.998 tell me? Boom! You now know how much you went to the right. I went to the right 0.998. Okay, so I went to the right 1. So I'm going to be around 5. Now we could find that value. So let's go into our home screen because this is easier to do. I have my position at 0, which was 4. And then I'm going to add my displacement from 0 to A. A is still stored. 3 log x sine x minus 2 minus 3. Not fun, but once you have it in, it's great. Give me something around 5, right? What's happening? Your calculator is working hard to find the accumulation because the functions are so crazy. Look at that. That was like 4 plus 1. All right, 4.998. Let's find our position at time B. Well, you can calculate the area from A to B. Go second, calc 7. Let's go from A to B. Now you can visually see this. Look at this area and compare it to this one. It's going to be a bigger number. It means I'm traveling to the left a bunch compared to how much I travel to the left, right. So how much? About 6.175. Okay, so I travel to the right 1, I travel to the left 6, and we can find that position. Now, what's great is like you got options. And somebody asked me earlier, they're like, what if you have 2 positions? Like, well, you can choose. How can you find x of b? I can either say, take x of 0 and find the displacement between 0 and b, or you could take x of a and then go to the left 6.175. Find the displacement between a and b. So let's do it both ways. We could either do 4 plus my displacement from 0 to b. I'm going to end up to the left of both. So I start at 4, I go to the right, I then go to the left. 6, I'm probably going to be at a position around -1. Working. Accumulating. We'll find this is why we never graph an accumulation. We never graph an integral because it'll take my calculator forever. There you go. -1.176. But let me show you the other way I could have gotten that. I know my position at time A. I will add my displacement from A to B. Just going to go back and erase this +4. I could have said my displacement from A to B, that left 6, boom. I get that -1.176. All right, 2 ways to do that. Whichever way works for you. And then our last candidate is at 4. Now you could, if you wanted to, in your calculator, and it's nice to visually see it, so I'm showing you, find the area from B to 4. And you will find how far you travel to the right at the end. Just 0.6. So, what happens? I started at 4. I go to the right like 1. I go to the left like 6. And then I go to the right 0.6. Do you think x of 4 is going to be like my max? No. It looks like right here was my max, and then right here was my min. And that's the idea about things. You know, we're kind of combining stuff that we've already done with stuff we just learned about areas, displacements. Now we can be given the graph of f prime on a closed interval and definitively find locations of maxes and mins. And I'm just going to go 0 to 4 here. But again, I could use this. I could use this. It's up to you. If you just wanted to take your position at time B and then take that and add the area from B to 4, which was +6. Four plus 0 to 4. If you didn't understand the displacement lesson, this is going to seem like crazy. If you don't understand motion, that the area is telling you how far you're moving, this is going to seem weird. But if you have been like working throughout things, you understand why this has to be my max, which is when I'm furthest right, and that's the position at this time. And then this has to be the min, that's the left position, furthest left, and that would be at this time. It's a lot of work, right? I mean, it is if you explain it every step along the way, but if you're used to using this, all you're doing is finding a couple of intersections with the x-axis and then reusing this formula over and over and over again. Okay? You'll find this in your homework. Why don't we just like start on your homework? So, I believe the interval's from 0 to 7 on your homework. I think it's the second page of your homework. Third page of your homework. T sine T. The bottom left, third page of your homework. Now I make it complicated. I don't tell you that x of 0 is 2. I'm not nice to you. On your homework, I tell you x of 4 is -2. That actually makes things more complicated. Okay? All right. I want to figure out when and where am I furthest right and furthest left. I'll make it easy on you because I'm going to tell you where the intersections are. You don't have to find them and use crazy values, okay? So go ahead and graph V so you understand motion from 0 to 7. Let's pause. Forgot to change your window and it's taking forever to graph. Press on and that's a pause. And then you go window 0, 7. Great, thanks, Mr. Messer. We got 2 changes of my velocity, which means I have a total of 1, 2, 3, 4 candidates. I got my start, my end, and then these 2 zeros here and here. I see my velocities positive, then negative, then positive. Zeros of my velocity are zeros of the derivative of position. It's how I'm going to tell when my position's at a max or at a min, or when I'm furthest right, furthest left. Now, here are those intersections. Pi, 2 pi. All you need to do is find, if you want to do this quickly, what x of 0 is, what x of pi is, what x of 2 pi is, and what x of 7 is. If you wanted to do a little bit further investigation, you could figure out how far are you going to the right? How far are you going to the left? How far are you going to the right? It looks like I'm going to the left a lot. Now, going to the right and going to the left a lot probably more means like this would be when I'm furthest left. Going to the right a little bit. I don't know if this plus this would overwhelm this and maybe I end to the right of where I am here. No, definitely not. This would be furthest right, this would be furthest left. But anyways, like that might seem like a little complicated and actually go through all that process on the homework video. But instead, let's just like get the home screen out. Let's get our integral out and let's understand what to plug into it. Now, what's complicated about finding x of 0, x of pi, x of 2 pi, x of 7? That wasn't last question we did. There's a given. X of 4 is negative 2. What's complicated about that given? It's in the middle. It's smack dab right here. Oh, great. You gave me a position at time 4, Mr. Messner. You made it so easy for me to do. Sorry, I didn't. You have to find x of 0 by doing your friend x of 4 equals x of 0 plus integral from 0 to 4 of v. You want to find x of pi? X of pi is in the past. So you have to do x of 4 equals x of pi plus integral from pi to 4 of v. X of 2 pi is in the future, so you could do x of 4 plus integral from 4 to 2 pi. X of 7 is in the future, so you use x of 4 plus 4 to 7 of v. Now, that's, that's not as easy. My integrals are changing. It always includes 4, but maybe the unknowns are inside my formula in different places. So what am I going to do? I'm just going to focus on my integral, the math 9, starting with 0 to 4 of v, t sine t. I get that. What do I have to do? Subtract that from negative 2. Negative 3.85. Okay, now let's find my displacement between pi and 4. All right, go over here. Like once you get the hang of this, it's like, it'll make sense. Okay, so negative 1.28. I'm going to have to subtract that from negative 2. Do the opposite, or add the positive value. And I get x of pi, negative 0.716. X of 2 pi, I'll need my integral, which you can grab, from 4 to 2 pi. And I get x of 2 pi is negative 8.14. Don't forget to add negative 2. I get negative 10.14. And finally, let's find our displacement between 4 and 7. I'm being cruel by giving you this initial condition. If I gave you a starting point or an ending point, that would help tremendously. But I'm just kind of like making sure you're comfortable with any way of doing things. I still need to add negative 2 to that number that I just found. Negative 6.47. Negative 8.47. Here are my candidates. When my derivative is 0, it's my endpoint. When am I furthest right? Pi. When am I furthest left? 2 pi. You just did a homework problem. I never get out of the negative land. What would make these problems easier? Less sign changes, right? If there is just 1, 0, well, and they give you an initial point, well, then you just have to find 2 positions. They already gave you x of 0. You find this position, you find that position, you compare the 3. You win. You know how we're moving. You know how to utilize displacement to find unknown positions because you can't take an antiderivative. It's a combination of lesson 1 and lesson 2, to be honest, what we just did here. Okay? So that's it. You guys, by far, got the best lesson compared to the other classes. Paul.